Clean water, once safe, taken from any number of natural sources, must face today's challenges of industrial pollutants, agricultural runoff, and population shifting, requiring water management, conservation, and treatment so that the demands for safe water can be met. At Separmatic, responsible water filtration design begins with collecting information. To efficiently produce potable water, the source and condition of the water to be filtered must be known. It is equally as important to anticipate the supply fluctuations that occur during seasonal changes. They have to be taken into consideration. Water can be treated with chemical additives, ionization, light-based treatments, and mechanical filtration. These different technologies are often used together in series to reach the level of safety required for consumption. Separmatic has been providing solutions to water safety with an emphasis on water conservation and cost efficiency for 50 years. Removing dirt or suspended particles from water is simple filtration. Pathogens, which are contaminants not much larger than a micron, such as E. coli, Giardia, and Cryptosporidium, are responsible for a large percentage of infant deaths in many parts of the world, and for the thousands who will struggle to survive from consuming contaminated water this year. Separmatic has several alternatives to filter the pathogens from surface and deep water sources. Most often, for non-salt water requirements, Separmatic designs a diatomaceous earth system, often referred to as a DE system, for pathogen control. DE is a white powder-like material, the remaining skeletons of diatoms. Diatoms are a microscopic water plant that's mined much like any other mineral. Environmentally, the DE is neutral. With its net-like design, it can trap these particles, these pathogens from the water that are as small as half a micron and hold on to them. DE wastes very little water and it's doing its job. It provides an affordable alternative and it's available worldwide. It's very simple to use. DE tanks can be vacuum tanks design or pressure tank design. Pressure DE systems, such as the one pictured here, is a sealed unit and has some automatic functions built in. We'll use a vacuum system for this video so that we can see the filtering process as it occurs. The large stainless steel vacuum DE tank in this mobile water treatment trailer can produce over 100,000 gallons of water a day at full capacity. The plumbing includes the inflow line, a recirculation line, the outflow line, and of course, the drain from the bottom of the tank. The interior of the tank will secure several leaves that have a large surface area. Leaves are placed in a vertical orientation on vacuum system designs. Before a leaf is inserted, it must have a cover, also called a garment, applied to it. The garments only fit in one direction and will secure the leaf with either Velcro at the ends or the use of an O-ring which will slide over the leaf and hold the garment in place. Although garments are not disposable, they will eventually wear out and require replacement. In certain situations, the garment should be replaced annually. In some cases, less frequently. The covered leaf is attached to the manifold within the tank. Once that's done, it's secured in place with a bracket. The valves are then closed to allow for recirculation within the tank. The tank is filled with unfiltered water and is now ready for the fresh diatomaceous earth to be applied. The DE is not added directly to the main tank. Separmatic has engineered a separate baffled area where the DE is added slowly. The water within the engineered subchamber has been designed to control the force of incoming water. This is to protect the cake as well. The water becomes cloudy as the DE is mixed by the chamber. Water is now leaving the tank through the garment into the leaves and out through the manifold. And as the water continues returning to the tank and back out through the leaves, the water becomes clear as the DE is deposited on the garment. When the water clears, the DE is ready to do its job. The valves are changed to discontinue the recirculation bypass, and the process of creating potable water can begin. The time to prepare the cake averages about 15 minutes. Flow pressures are measured as the water is forced through the cake. When the pressure reaches 17 to 20 psi above what the initial pressure was, the DE requires what's called a backwash. Most backwash procedures require very little time to accomplish, about 5 minutes. The retail price of DE is about 20 to 25 cents per pound, and this system uses a little under 2 pounds of DE to produce the cake. To start the backwash, the pump that feeds the DE tank is diverted to the drain pipe at the bottom of the tank. As the standing water in the DE tank is removed, the DE cake falls free from the garment, still holding on to those harmful pathogens, and it is expelled with the tank water through the drain. A hose is used to spray off any resistant pieces of cake that might be clinging to the garment and to move any DE resting from the bottom of the tank. For larger systems, Separmatic has a water spray bar located above the leaves to automatically rinse off any remaining DE. Once clean, the tank drain is closed, and the pump again fills the DE tank with unfiltered water to a level where the tank can again go into a recycling mode, and the new DE is added for the process to begin again. How often a backwash is required is based on the quality of the water coming into the diatomaceous earth tank. Turbid water will clog the cake more rapidly. That leads to more frequent backwashes. This DE system incorporates a pre-filter that's placed there to reduce the turbidity from the incoming water and greatly extend the life of the DE cake. The pre-filter component is able to be bypassed if the water supply is of sufficient quality to go directly to the DE tank. Turbidity sensors are put in place to monitor the water that's going into the pre-filter. It then monitors the water coming out of the pre-filter and going to the DE tank. And a third sensor is there to monitor the turbidity of the water coming out of the diatomaceous earth tank. And all of these sensors are there simply to assure that the system is functioning normally. The system uses flow sensors as well, and all of this information is sent back to a central computer, which in this case for this customer has been mounted on the front of the trailer compartment, where storage space is also available. Another feature to this particular Separmatic system is a post-filter. Carbon block filters have been added to remove dissolved metals, gases, odors, and even tannin from the filtered water. The water is then pumped to a storage supply or where it will be delivered to the consumers. The Separmatic system in this video can provide well over 100,000 gallons of water every 24 hours. The mobile trailer that you see is 20 feet long. It's 8.5 feet wide and features some of the options that many clients want in a mobile water treatment system. The system provides dual doors, a work area with adequate lighting and storage, also a laptop station that would record all sensor outputs, and the frequency of service. Information that can help Separmatic as well to fine-tune the system to operate at its peak efficiency for our clients. And this Separmatic mobile system also includes a 7,000-watt gasoline generator, providing power when an emergency water supply is needed, but power just isn't available. Separmatic makes several different designs of trailer, and all can be customized. What you're seeing on the screen is a smaller Separmatic trailer that includes both a vacuum and a pressure system, capable of producing between 23,000 and 36,000 gallons of potable water per day. Now, Separmatic can produce stationary systems, skid-mounted systems, or produce tractor-trailer systems that could produce water for virtually thousands of people. We look forward to solving your water purification needs. Thank you for joining us today.